So this is our water filter challenge design slide. Okay, so our members consist of me, Alexis, Patrick.
Okay, so since NASA's been aiming to go to Mars by the next decade, there's been more discussion about how we would get to Mars and what we would do with the resources there. So we could potentially build a colony there or work with life on that planet. So one of the most debated topics regarding Mars as of recent is the water and how we would use it to the best of our ability, how would we make it sustainable, how would we make it clean and drinkable. So my group has been working to create a filter that would hypothetically be used to filter water on Mars in the future, starting with learning how to filter what we already have here on Earth.
All right, so the design for the filter, we started with a 4-legged stand to hold our 3-liter bottle, and then at the bottom of the 3-liter bottle, we put 2 funnels. The first funnel that was put on was actually able to fit, and that was what we used. The second one we tried to fit it on the first, but required another funnel to fit on. And then then we put all the filters in, the coffee filters, different layers of sandstone, limestone, different sands. And burlap is at the bottom of this, and then it goes through there. And once it goes through all of the filters, it goes through the burlap, it goes into a activated carbon chamber in the middle, and then after that it goes through the tube and then to the solar still, where we have a UV lamp and a heat lamp to evaporate the water and sterilize it, and then it drops down through another tube that goes to the end with a faucet where we collect the water.
So for the beginning of the sand filter, we decided to use a 3-liter bottle so we can remove the larger particles. First layer is extremely fine sand. The second layer has coarser sand. The third layer has small pebbles. The fourth one has small rocks. And the fifth layer has larger rocks. All of them are separated by coffee filters. And
oops, sorry, go ahead.
And one of the first things we actually did was we went down to the shop and we had a stand constructed so that we could hold up the bottle, and it would be like a higher elevation than the rest of the filter. Besides that, we started off by first cutting the bottle, and then we put on the two funnels at the bottom, and then what we did is we laid burlap at the start of the funnel, and we put coffee filters with each layer on top.
Okay, so our next part of our design is the purification. So we decided on an activated carbon filter. So the water enters from a tube that's attached to the funnels, and it passes through. We have half of our bottle is activated carbon, so no pieces of activated carbon would fall through into the drinking water. Yeah, next slide, please.
And the final step is the purification, which is the solar still, where we have the UV light to kill off the germs, and then the water will evaporate from our heat lamp, which heats it up. Sadly, that did not go as fast as we hoped for, including our sessions where nothing would happen. But it would heat it up, and then we had some rocks placed on some clear plastic wrap, where all the water, the CO, the water vapor gets caught and then forms back into water droplets, and then drops down the hole, which is the funnel, and then it goes to the end where the faucet is, and we collect that.
Hold all the water until we would decide to open it. We would make sure the bottle underneath or cylinder container that would catch the water. And so with this stuff, it was a good idea. We would have, since it would be so long for the process to go all the way through, at least we would be able to let it collect for a while, and then whenever we would get back to the filter, we were able to access all the water at once. So we didn't have to worry about keeping a container out there at all times, which is what we were initially going to do. So, good idea.
Okay, so going off of basically everything you said, just from the point, because so starting off, we have our filter. Patrick went through and explained everything we had. Our layers that are fine, our coarse sand, pebbles, I think it was limestone, and then sandstone. And everything is sealed by a silicone, water-safe silicone. And then it's all attached on a tube going down into our activated carbon filter, which is have our activated carbon have burlap, sorry. And then that is connected with epoxy. And then these two black things over here is water resistant duct tape, which was a lifesaver throughout this, this entire process. We're really good friends with duct tape as part of this project. And then once it runs through, it goes down into our solar still, where the lamp is heating it up, and it's condensing, creating water droplets that are, with the pressure of the rock, hopefully, well, they did fall into the funnel, which collects down into a tube where we get the rest of our sample.
We had to make sure to use this fabric, so that we would hold up the lamp at a proper height, so it wouldn't heat up the plastic too much until it melted. And at the same time, we wanted it to be close enough to actually evaporate the water. This is the list of materials that we use.
Before we put it into the filter, the phosphate levels 6 or 7, pH was 5, salt was at 10, turbidity was 559, and nitrates was 145. Interrupting the project. All right, so we managed to get the turbidity test on the sample before some complications occurred. That was at 51.4, and then pH went to the base of 7. Nitrates was at 1, phosphate was 0.6, and salinity, we just switched to a different type of test, that was at 20%.
This top photo of the clear water, that was from before we made some revisions to the actual design. Because at that time, that was actually the water that had leaked out. And we had a problem where when we had the epoxy setting, it actually tore. And then there was a spot where all the water started leaking out. And since we were struggling to catch some of the water coming out of after completing the entire process, we decided to use some of the leaked water, which actually turned out to be pretty clear. This one on the bottom, this bottom photo underneath that one, is from the more recent testing.
The one that had complications.
Yeah, the one with complications. This was after we had fixed the leaking issue, and we made some adjustments to make the design just slightly more compact, just like cutting down the tubes a little bit. This over here is the water that remained in the solar still, the stuff that wasn't evaporated. It must have oxidized or something because it was starting to have some particles form in it.
The tin foil was also starting to bit brown. Some of the issues we had on the project, it would take forever to evaporate the water and get it to collect at the end. Like that sample we had, that was after it didn't rain on it at the beginning of the day. That was after like an entire school day's worth of the solar lamp running. The first time we did it, before we changed the heat lamps and everything, it went really well. Like we collected a lot from the solar still, but not sure what happened afterwards. As we kept at the same height level, same distance. The only things that were really changed were the lamps.
Same light bulb though.
Yeah, it was the same light bulb, but like
we changed light fixtures.
Yeah.
That shouldn't have made a difference. You're still getting the same wattage.
so there was something that we didn't account for that changed.
Yeah.
And then, yeah, at the beginning of testing, we had a lot of leaks. A lot.
We had to try and heater running through water.
We filled that up all the way, like, almost all the way. And then,
The epoxy.
yeah, epoxy issues, that was one where it broke off and that leaked after you tried to reseal it. And Randy thought it was a good idea to wrap in like 6 layers of duct tape. Yeah, that one. And then another complication was the water bottle. Someone took that.
Yeah,
Something happened to it.
We don't know.
No, but
we have more sample from Tuesday that we had collected when school's over. It was a lot of water too. and we placed it there. Said goodbye to it.
And then,
Miss Kelsey threw out the sample by accident.
some improvements that we can make is to first make it so our design evaporates the water faster. And another major part is our design is not that solid. Like, we require multiple people to move it, so a way to make it more compact would definitely be nice. And then the coffee filters, that was a pain. We had to replace them. Like right now, if we were to run another sample, we'd have to replace all the filters again. And then, yeah, what I said before with the stills. Yep, that's
Yes.
everything.